Hi, this is Lê Quang Thi Nguyễn from Group 11, and today I would like to introduce about my project, which is music analysis and the recommendation system using Spotify API. So, I think you at least one time whenever you listen music from the internet, you may wonder how music platform like Spotify or SoundCloud or Pandora may manage to recommend songs to us. And these personalized playlists are being recommended by grouping similar songs that go well together and then recommend to you some unheard song that these people like listening to. And my data source from Kaggle with include 26 genres and a sum of more than 200,000 and 700 tracks to forecast the user's interest and recommend the most likely to be interesting service. So first of all, we need to set up the environment and import all necessary libraries and package before doing any Python code. And I decide to store my dataset from Google Drive. So my dataset can store permanently at Google Collaboration with the delete whenever I run in circle time. And you can use the path code to read the datasets, which we already create a folder inside the drive of Google Collaboration. And here we read the dataset with hit function, so it will return top 5 rows of the data frames. You might obviously the dataset may show this is the song level with genre, artist name, track names, and you may see some of the variables like accordionness, danceability, energy, or instrumentalness, and so on. So these are kinds of technical descriptors of any particular songs. And next, we need to double check if have any new values exist in the datasets. And thirdly, we gonna discover a music taste of the datasets by using histogram to analyze which music features is popular at this data. And we need to be remember to run histogram. It should be in the numeric data types. So before that, we should double check with the data type and see not all of them in numeric. It have to combine between numericals and non-numericals. So we have to drop all of non-numeric data like artist name, tracks name, keys, time signature, mouse, etc. So the data here, the new data here is all of the number. Then we run this function to show the histogram, and we can see the collection of genres that satisfy the result of this histogram, which is the mostly is a cappella, alternative, anime, or blues. So all of them have the high danceability, lowness, energies, and valence. And another way to double check music taste by using radar charts, by using the min-max scaling to normalize the features of music. And here it quite the result seem quite similar with the histogram. And we can see most of the music tastes are the loudness, danceability, valence, and a quite more here with occultedness. Which is again occultedness from at the range of 0 to 1, and quite a highs at a 0, which is low occultedness. And there is a couple of models that can use to analyze music features before creating a recommended tools. So we need to consider about random forest, k-nearest neighbor, logistic regression, and decision tree. And before that, we should split the dataset into training and testing, and then we can compare those models together to pick the most suitable model to use. Visualization by using bar chart with those cards, and the result indicate that random forest is the most suitable for this data sets. And next we should hyperparameter it for the random forest. So it quite like the setting of an algorithm that can be adjusted the optimal performance. In the case of random forest, hyperparameters include the number of decision trees in the forest and the number of features considered by each trees in when splitting a knot. We can see the prediction and actual features of this. The last part we about the recommendation system. So mostly they have two types of recommendation system, which is content-based filtering and collaborative filtering. And I would like to use the content-based, which is use a characteristic information that recommend new items to a user based on their past action and based on the feedbacks. So to do that, we need to use a cosine similarity metric to implement the dataset playlist recommender quickly. So I would like to talk a bit about the cosine distance model. It have two items or two vectors, which one is playlist vectors and the second one is song vector. So the angle between the vector, which is cosine distance, similarity. So whenever the smaller the angle, the higher the song score, so which means the better recommendations. Yes, I have a function use the cosine distance to find the similar track. Playlist of similarity songs here. And next, we want to connect to Spotify API, so we need to have client ID and line secret. I took directly from my dashboard at Spotify websites. and those got to access the API. I have this function here that check an input which was place I want to book based on artist ID. But it will show the list album of this artist ID that I have. But it also one of my limitation because I haven't tried to predict the top 10 or top 20 of songs based on other user behaviors. And yes, so from to wrap up the projects, I have some limitation which I haven't tried, some limitation that I need to know that the dataset have multiple variables, so it's difficult to decide which variable to use and which variable to discard. And the work of music is beyond the reach of just this API Spotify, and there are many other external unmeasurable factors that could determine the success of certain music songs. And the last one, the Kaggle dataset doesn't have any conclude for a certain year, so this might restrict me to do some broader analysis with the evolution of music. And yes, that's all I have for this presentation. Thank you so for listening to me.